Good morning. These are the very important examples on the Cauchy's integral formula, and here we need to evaluate this integral where C is a circle mod z equal to 3, right? Because I'm having the point here z not equal to 2, we need to check whether this point lies inside the circle or not. Yes, this circle is of radius 3, right? So definitely this point z equal to 2 lies inside this circle. So for this reason, we are going to apply the Cauchy's integral formula to evaluate this integral, right? And secondly, we need to check what should we write for fz. We always take the fz to be the numerator, right? One more thing, if I am having one more bracket having z minus 4, now this 4 point does not lies inside this circle, right? This circle is of radius 3, 4 point lies outside the circle. In that case, we need to take our fz to be numerator along with this bracket in the denominator, right? Then take your fz to be equal to this. But in this example, we are having only one bracket, z minus 2 to the power 3, and z equal to 2 points lies inside this circle, so we are taking fz to be equal to this numerator, right? Okay, so here let's take our fz to be the numerator 3z to the power 4 plus 2z minus 6. And because we have to apply the Cauchy's integral formula, what is that? It is the integral of fz divided by z minus z naught to the power n plus 1. Now here what is n? Here n is equal to 2 because we are having n plus 1. If n plus 1 is equal to 3, you get n equal to 2, right? So when we apply formula, we have this result to be equal to 2 pi iota divided by n factorial f, the nth derivative of f at the point z naught. Now here what is z naught? Here z naught is equal to 2, right? And n is equal to 2. So this is how we apply the formula. So to use this formula, we need the first derivative, we also need the second derivative. Because here n is equal to 2, so we need the values up to the second derivative, right? Okay, derivating f with respect to z. So it is 12z to the power 3 plus 2. Derivating this again with respect to z to get the second derivative. So it is 36z square. That's it. Now this fz is your polynomial, so it is analytic inside the circle. It is analytic inside the circle and also on the circle. Now what is this? The nth derivative, that is the second derivative at the point. What is z naught? It is 2. Z naught point is 2. For this we take z naught to be equal to 2. So we need the second derivative of f at z equal to 2. It can also be represented as second derivative at z. So what is the second derivative at z equal to 2? Just substitute z equal to 2 over here. We get 36 into 2 square. So that is equal to 36 into 4, which is equal to 144. So this is 144. Now since fz is analytic inside and on the circle mod z equal to 3, analytic means it is differentiable everywhere, and the point z equal to 2 lies inside the circle. It is analytic everywhere except at z equal to 2, because at z equal to 2 the denominator becomes 0. So the complete function is not defined. So function fz is analytic inside and on the circle, the given circle, and the point z equal to 2 lies inside the circle. So by Cauchy's integral formula, we write this integral to be as, it is your fz divided by z minus 2 whole cube dz, which is equal to 2 pi iota divided by, if I am having 3, just subtract 1. So it is 2 factorial. If I am having 3 power, take the second derivative. You can also mention this as the second derivative at z equal to z naught. What is z naught? Here z naught is equal to 2. This one. So 2 factorial is 2. Cancelling this with this, and we have this to be pi iota. What is double derivative of f at z equal to 2? It is 144. So the answer is 144 pi iota. That is the required answer for this given integral. Okay, thank you.